Okay, so let's do call this relative velocity 2. We'll just ramp up the difficulty a little bit here. Okay. Now, some people call this like a Superman problem. We'll do an example with airplanes. Um, you know, uh, and we'll just say something like this. The plane must hold a heading of, let's say, 40 degrees south of west um, while flying between two cities. Okay. In order to arrive on time, it must have a ground speed of 300 meters per second. If a 50 meter per second wind is blowing, at 30 degrees east of south, find the air velocity of the plane. Okay. So it's pretty tough to keep something like this in your brain. So the key is to always draw a picture. All right, so here's where the airplane's flying from. Here's where they're flying to. Okay, grab ourselves a little. Okay, and we said that along this route, in order to arrive on time, we've got to have a resulting value of 300 meters per second. Okay, and we know that this is 40 degrees to the south of west. Okay, and then we said there's a wind blowing here. Okay, the wind is blowing like here. We said that the wind was 50 meters per second and that it is 20 degrees to the east of south. All right, so now if the airplane just like aims itself down here at the city it's heading to, it's not correct for the wind. It's going to end up flying down here somewhere. All right. And instead of 20 degrees, it's actually 30 degrees. So let's just fix that. See? Picture. It's worth 1,000 words. 30 degrees east of south. There we go. Okay. Anyway, everything else still stands, just the number changed. Okay. If we do not correct for this wind, we're going to end up missing our destination city. Okay. Which is probably a beautiful place that we don't want to miss going to. So in order to correct for this, we're going to have to aim up here somewhere. Okay. So the way to solve a problem like this is to actually make it so that this ends up being, this ends up being our result. Okay. So we're going to take this guy, move it up here. We're going to have to fly up over here, okay, such that the wind blows us back on track. And technically what we're doing here is we're doing what's called a vector subtraction, okay? And vector addition is adding tip to tail. And if you remember, vector subtraction is adding the opposite vector. So the opposite vector of 30 degrees east of south is 30 degrees south of east. No, it's not. It's 30 degrees west of north, okay? 30 degrees west of north, okay? So we want to take our 50 meters per second and we want to go up over there, west of north. Oh my. Struggling. We'll get there though, okay? So there's to the west of north. So we're adding the opposite vector. So what we're actually trying to find then is that one. Let's just change it so it looks a little more exciting orange. Okay, so we want to find this. If we fly here, the wind blows us back where we want to go. So when you see a problem like this, just try to be logical about it, right? If I want to go here, the wind's blowing here, right? If I don't correct, I'll miss down here, so I got to fly up into the wind over here, all right? So we're trying to find this guy here. We got to find this guy here, okay? So in order to do that, we have to add two vectors. We have to add 300 meters per second at 40 degrees south of west to the opposite of the wind, right? So 50 meters per second, 30 degrees west of north. All right, so there's vector A and vector B. So now it's just a normal vector addition problem like you would do with any other vector. You got to find the x and y components of each one, sum the x's, sum the y's, and find your new vector. Okay, so we'll go through that. It's a little time consuming, but I think it's worth it. So put that down there. Okay, grab the components of that thing. So there's its x component, there's its y component. Then the numbers that we know, 300 meters per second there. This is a 40 degree. Okay, so this is going to be 300 cos 40 degrees, and that is going to be in the westerly direction. Okay, and this is going to be found as 300 sine 40 degrees, and that's going to be in the southerly direction. That's right. Let's go ahead and do those. So we'll call this vector A. We'll say that AX is the x component, right? The horizontal, and this is the y component. AX is 300 cos 40 degrees. That's going to be in the westerly direction. And then AY is 300 sine 40 degrees, and that's going to be in the southerly direction. So there's our two components, 229.8 to the west, meters per second to the west, and the southerly component is 192.8. Okay, to the south. And then let's do our new wind value. Okay, so wind is up over here. Oops, let's get a nice arrow. So wind is up over here. Okay, it's going to have an x and a y as well. Y. X. Okay. This is 50. That is 30 degrees. Okay. So this is 50 sine 30 degrees, and that is to the west as well. And this is 50 cos 30 degrees, and that is to the north. And this is vector B. So Bx is 50 sine 30, and By is 50 cos 30. Okay, so do your mathematics, 50 sine 30, use 25 meters per second to the west, and then 43.3 to the north. Okay, so now we have to do our resultant vector. So we need AX plus BX. We say that our resultant in the X is AX plus BX, or our Y is AY plus BY. So our X's then add up to 229.8. Plus, and they're both in the same direction, they're both west. Okay, you know, we'd often maybe put negatives. It's not really necessary if you realize they're both to the west. We just go ahead and do that. So we get 254.8 meters per second is the west component of our u vector. And then if we talk about y's, we've got 192.8, which is south. So negative 192.8, right? And then we've got 43.3, which is north. Let's see what we get there. Okay, so we get a negative 149.5, which is just like saying 149.5 in the south. Okay, so the last thing we have to do is we have to draw a new vector triangle, okay, of this plus this. And what that should do is it should give us this, this orange guy. Tell us where we need to actually fly our plane in order to end up where we're going to really end up. So this is quite an involved problem. It takes like quite a bit of thinking to solve it. So first question, the angle that we're going to find here to the south would be greater or less than 40 degrees? It's probably going to be less than 40 degrees, right? So we've got to fly kind of towards the north from that 40 degrees. So hopefully that's what we get. If we don't get that, then we've probably done something incorrect. So two things, find this and we find this angle. So to find the resultant vector, r, we're going to have to find the root of 149.5 squared and 254.8 squared. Okay, so in doing this, we get a value of 295. Sorry, 295.5 meters per second and an angle of 149.5 over 254.8, which should give us 30.4 degrees. Okay, the pilot must fly then at 295.5 meters per second at 30.4 degrees south of west. Okay, and then the wind, which is blowing like this, will blow them back onto course at 300 meters per second. Now, is this checkable? Can we check it? We absolutely can check it. So what we can do is this. We can say, let's see what happens if you fly that angle, and then you add to that the correct value for the wind. So 295.5, 30.4 degrees south of west. And to that, you're going to add your wind, your actual wind, 50 meters per second, 30 degrees east of south. Add those two vectors, and you will find that you get 300 meters per second at 40 degrees south of west. Go ahead and try it.